Alrighty, so for example 5, we're using case 2. Again, we have linear expressions, and we also have some repeats, right? So essentially we'll do the x plus 2 for 1, then we'll do x plus 1 to the first and x plus 1 to the second. So that's where this is coming from, okay? Because they're linear, we'll just do letters on the top, or variables on the top, okay? So we have A, B, and C. From here, we just rewrite this top portion, and then we write our A, B, and C and multiply the A, B, and C by what they're missing on the bottom. So our goal is to have all the bottoms look like this, right? So for our A, it's missing the x plus 1 squared. For our B, it's missing one of the x plus 2 and one of the x plus 1. And then for C, it's missing this x plus 2, okay? From here, we can try to do it just like we did example 4, where we get rid of all our parentheses, we FOIL this out, then distribute our x, FOIL this, distribute our B, and then distribute the C, and then try to set this stuff up. But as you see here, it doesn't actually spit out like it does the last time. So I'm going to show you a different way to go about it, or how we did a previous one, I think example 3. This way can still work, but I'll show you how to do that on the next example, okay? So there's multiple ways to solve problems. Just make sure you don't make anything up. All right, so we're going back to this line up here. I've just rewritten it, and essentially we're going to do the same thing we did before. So we need to figure out what we can plug in for our x here to get rid of two of the letters, either A and B, or B and C, or C and A, so we can solve for the other one. So we need to look at what 2 of them share and 1 of them doesn't have. So both of these share, B and C both share x plus 2, and this one doesn't. So if we let x be -2, we can get rid of B and C and solve for A. Makes sense? So we plug in -2 on this left-hand side, we get 3. We plug in -2 here, and we just get A. Okay? And then we just go through that process again. If we let x be -1, and to get rid of A and B, and we find C. And then if we let x be equal to 0 in this case, it doesn't get rid of stuff, but it doesn't really matter because we already have B and C, so we can always just plug in, okay? So the last one, you can really just plug in whatever number you want to, whatever's easiest for you. 0 is usually the easiest, and solve for the other letter, okay? So now we're going to rewrite this as the integral of this expression here and plug in our new A, B, and C, okay? So now we have this new integral. Remember, whenever you have these powers on the bottom, it's best to use U substitution and then bring it to the top, okay? If there's not a power on the bottom, you can leave it on the bottom, and we can use the natural log absolute value trick, okay? The derivative of both the bottoms here are both 1, so this 3 is just going to come to the outside, right? So essentially this is going to be 3 absolute value of the bottom. Y'all see that? When we take the antiderivative, I just skipped all the way down here, okay? And then over here, same thing. We'll have this -2, because we always take the sign, natural log x plus 1. I actually don't know why I plugged in the U here. You didn't need it, okay? So -2, natural log, absolute value, x plus 2, okay? So now we have these first 2 sections. This last one has the squared, which is really where we need to use the U substitution. We didn't have to use the U substitution on the first one. I don't know why I did it, sorry. But it still works as long as you don't make math up. But yeah, so we do our U substitution. We let it be the stuff on the inside. We take the derivative, and then we plug it in, okay? So when we have this, we can change this to the top by saying U to the -2. And then when we take the integral of this, we add 1, which gives us raised to the -1, and then we divide by that -1, which is why the signs have flipped, okay? And now, we've taken the integral, so we can just put our U back, which was x plus 1. Because it's negative, we're going to move it to the bottom. And that would be our final answer.